This video explains seasonal adjustment forecasting idea. Seasonal forecasting idea looks like this. If we have some data trend like this, that is up and down. So then we have, this case, we have some trend. Also, we have some, seasonals. So seasonal means there must be some up and down based on our season. Basically, quarter base or actual season. I mean, spring, summer, fall, winter season, right? This is seasonal factor. To forecast this idea, first of all, we have to deseasonalize. If we deseasonalize, then we have this kind of a trend. If we have this trend and we have some up period and then down, up and down, something like that. First of all, we have to deseasonalize. If we have deseasonalized information from this deseasonal, this is a linear trend. For linear trend, we can use a linear regression idea. So you apply linear regression, and later on, with the linear regression, we might have this kind of a linear line. And with this linear line, and we have to multiply our seasonal factor. If we have up period and we multiply our seasonal index, then our final forecast looks like this, up. And later on we have down period, then we have down, and so on, like this. So this is our, the line is our linear trend, and this is, if we multiply seasonal factor, then that is our final linear regression. So first of all, we have to deseasonalize, and if we deseasonalize, then we have seasonal factor, seasonal index, and if we have this seasonal index, later on we multiply those seasonal index to our linear trend. That's key ideas of this seasonal adjustment. First of all, to think about, think about seasonal factor. If we have this seasonal ideas, then if we take average, we have to take average, then that is deseasonalize. That means what? We have to take this up and this period and down, and we have to take into account all these basic seasons, right? Spring, summer, for winter seasons, we have to take all season year-wise. Then we have the deseasonalized information, right? But however, if we have 4 seasons, Q1, Q2, Q3, Q4, then what is our center? Actually, our center is if we have Q1 and the Q2 and the Q3 and the Q4, if we have a Q3 and the Q4, which one is the center? Center is actually, this is the center, right? This is center. But for this center, we do not have a index for this center. So that's why we shift one more place. Actually, we use center for Q3. So if Q3 is our center, then if you take into account all these 3 periods, then it's not balanced. It's not balanced, right? From this center, from Q3 case, we need a balanced period. To do that, from this point, and we have a Q2 and Q2 and Q4. They are one period early, one period later. Then also we need another Q1, right? So then to balance this period, we need another Q1. So then now we have from Q3 standpoint, we have one period early, one period later, right? Q3, Q2, and the Q4. And at the same time, we can take into account the Q1 and the Q1 again. But we don't need to take into account twice for Q1. So that's why we have to give some weight for this early Q1 case, we give what 50% of Q1. So this is also 50% of Q1. Then in total, we have only one Q1, right? So that's why Q3 standpoint, we have to take into account what Q3 itself, and the 1 period early, 1 period later, and the 2 period early, 2 period later. So, but the 2 period early, 2 period later case, they are same, identical. So that's why we have to assign 50%, right? So we have to use this kind of a centered moving average first. Then if we take into account this centered moving average, we take into account all 4 seasons, means this is DeSeasonalize information. So with this seasonal information, we divide by this DeSeasonalize information, then we have seasonal ratio. So with this seasonal ratio, we can compute the average, that is adjusted seasonal factors. Then now we will add all this information, and then we can compute this CMA, centered moving average, and the seasonal index. So let me start. So here we have Q1 information, Q1, Q2, So at very first we have a quarter. We just define the name quarter and the period information and the actual sales, and so on. And first we have Q1, Q2, Q3, and Q4. We repeat this, so I just highlight this, and then we repeat this one. And period will be 1, 2, 3, and 4. So we just highlight this. And actual sales 108, 125, 150, 141, 116, 134, 159, 152, 123, 142, 168, 165. At the very first step, you have to visualize this data, right? So very first step, visualize data. And if you visualize data, you can plot this one. Then you can think about this kind of a trend. There must be some up and down. Also, there must be some, upward trend, right? So that's why we can take into account, trend as well as, seasonal factor. So first of all, you can compute the CMA, centered moving average. For this 4-period case, if we have a 5-period case, exact period 3 is our center, but for this case, we have an even number of seasons, 1, 2, 3, 4, right? That means we do not have a 2.5 seasonal index, so that's why we just move one more period, just half period. Then we have Q3. Q3 case, we have what? Q1 case, we have to multiply 50% plus Q2 is just ones, Q3 ones, Q4 ones, and finally again Q1 case 50%. So then at period 3, quarter 3. So we take into account this 5-period, right? From 5-period, this 5-period, we have exact same, number before and after, right? So then we can divide by, there are 4 seasons actually. Q1 case, we have half and a half. So total seasons will be 4. So we can start, we skip first 2, then we can skip last 2 as well. So this is our center moving average. This center moving average, if you look at this center moving average, this looks like, very similar from the season, across season, right? That means this is DeSeasonalize information. And you can compute the actual sales divided by CMA. This can be our seasonal factors. So we have these seasonal factors. you you have these seasonal factors, then period 1 you have 1.1, and next period quarter 3 1.1, and the next Q3 also 1.13. They are very similar, but they are different. Then we can compute our average number Q1 and Q2, Q3 and Q4. So for this you can use average if function. So for every if means what? We can compute the conditional average. So we can compute the average for all Q1. So to do that, we just compute this average range. This is range, and then we can fix this range, and the criteria is like this. And then later on, we can compute this seasonal index. So actually this is the seasonal index, and also we have to compute this seasonal index is our original, but this is raw seasonal index, but we have to adjust this seasonal index. Adjusted seasonal index. Adjusted seasonal index means what? So we have individual seasonal index, but this can be different over year. So that's why we have to take the average, and this sum of average should be 4. Otherwise, we have to adjust again. How can we adjust? So we can adjust this number later. So actually, we have to adjust how. So number divided by this number times 4. So this is our exact adjusted number. So that means what? So actually, I have to fix. Means if we have 4 seasons, then if we add all seasonal index, then should be 4, should be equal to 4 exactly. So we have to use this adjusted seasonal index. So now we will use this seasonal adjusted seasonal index. To do that, we can use a VLOOKUP function. VLOOKUP is we just use this seasonal index, and the table should be these numbers. Then we have to fix, and then now column index. Actually, we are using third column, and we have to use exact matching. Then we can use 0. Then we can refer these numbers. So this is our adjusted seasonal factor. So now we have these 7 steps. We have done at the very first step, so we compute the CMA, and the second step we compute the seasonal ratio, and third step we have to compute the average seasonal numbers. So that's why we compute this, and we add this adjust seasonal factor. Now next step we have the DeSeasonalize. How? We just divide by this seasonal factor, and then we have DeSeasonalized demand. To get this seasonal demand, we have to divide by this seasonal factor that you have this seasonal number. So if you have this seasonal number, then now I will plot this chart again. I will highlight this actual data and this DeSeasonalize data. If we remove this seasonal impact, then we might have only trend only. So like this, we DeSeasonalize, and this orange is our let me see. So I have some problem here. I have some problem. So Q1 actually I missed this uh, uh, range. So I missed this part. I'll draw again. So then I fix everything now. So actually, if we have this, average exactly, then we don't need to adjust. Actually, the sum of all these total number is exactly 4. So actually, I don't need this step here. I just delete this. And also for this seasonal factor case, we just use, I will do it again for this one. So here we have VLOOKUP and lookup value, this seasonal name and table, command T, and the second column and 0, and we have this. So we have this DeSeasonalize, seasonal index, and then now if we plot this DeSeasonalize demand, and then now if you look at this chart, and blue is actual sales, orange is DeSeasonalized demand. This DeSeasonal demand, it looks like a linear format, right? Then we can apply linear regression. So this is the second chart. And now we want to forecast linear trend. To get linear trend, we can use a linear regression. So to use linear regression, so you can use data analysis, and then from here you can click regression, and then click OK. And here, what is Y? Y is actually your deseasonalized data, and X is your period information, but you have to use exact the same period. And the first data is a label, and you can click this. Then finally you will have this linear regression result. With this linear regression result, and we will use this coefficient. So simply you just highlight this, and then you can add name. So name should be intercept and then period. So we will use this name. I'm going back to original data set here. So we can use intercept plus this period times and period index and the period index and the coefficient, right? And this is your linear trend. So we can forecast a linear trend like this. Simply we use linear trend equation, intercept A plus BX format. And finally, our final forecast should be, your linear trend is simply linear. There is no seasonal factor, so we multiply now. Again, we multiply our seasonal factor. Then if you have a downturn, and you multiply less than 1. If you have up, and you have upside up seasonal factors. So linear trend, so we will draw this chart, actual, and highlight other two. Then we can insert this chart, and we can compare. Then if you look at this, and the blue is actually very close to gray. So blue is our actual, and gray is our final forecast, right? And the green, yellow is our linear trend, linear forecast. So with this linear trend, we multiply our seasonal factor exactly. So then for downturn, we multiply seasonal factor, which is less than 1. Upturn, we multiply seasonal factor, which is greater than 1. So that's why we have up and down like this. So also we can forecast the future next 4 periods.